white. Okay. And only when they are stimulated by various forms of injury. Okay, yeah. Injuries such as axe chopping, nailing, holding, burning, inoculation of fungi, or injection of liquid inducers. And naturally, they were formed by stimulated by insects biting, lightning striking, and so on. Usually, several years after injury, so white wood here, this pattern, will turn to brown or even black, which means the resonance are formed, which we call it Agarwood. Here's a picture of Agarwood is like this. Here is after here the white wood becomes Agarwood. So we clicked. After clicked is like this. And here are some pictures of Agarwood. Here also Agarwood, and from different trees and from different methods to produce Agarwood. And for the Agarwood original trees, until now, 21 Aquilaria species have been documented that can produce Agarwood. And they distributed in tropical and subtropical area from India through Burma, Laos, Vietnam, and Cambodia to Malaysia, Sumatra, Borneo, the Philippines, and Papua New Guinea. And look at this picture. The area here with the green is the place where the native Aquilaria plants growing. Here is two pictures for the Aquilaria sinensis. The flower is yellow, and here is the seeds. When it can be harvested, here the seeds will be open. Here, this is actually the fruit, we can say. Here is will be open, and the seeds inside will come out. And this table lists the Aquilaria trees and their distribution. In China, we have 2 species, including here, this is Aquilaria sinensis. This one mainly distributed in Hainan province. In Chinese name, we call it Tu Chenxiang, Bai Mu Xiang also. And another is Aquilaria wala, Aquilaria yunanis. This one mainly distributed in Yunnan province. And we also call it Yunnan Chenxiang. And of course, in Indonesia, here we also have a located species named Aquilaria filaria, and we call it Si Chenxiang. And Agarwood are used very widely, mainly in 3 parts, in traditional medicine, perform, and decoration. And in China, Vietnam, India, and Japan, it is used as traditional medicine to treat gastric problems, cough, and high fever. And due to its present aroma, it has been also used in religions and also for ceremonies for already for centuries. And in recently, it is already become one of very welcome resource of perform here. It is perform, and it is also used to produce bracelet and other ornaments. For example, like this. So for this, usually like people like to take on the arm. And as a traditional medicine, Agarwood is listed in Chinese pharmacopoeia. It records as Agarwood has the function of 行气止痛，温中止呕，纳气平喘。Which means Agarwood can promoting qi circulation to relieve the pain, warm innards, and stop vomiting, and also relieve the asthma. So, and the modern pharmacological research showed that Agarwood has bioactivities including anti-inflammatory, antibacterial, anti-cancer, and anti-diabetes, and so on. So our question is, Agarwood is so welcome, but there are so many results, including they come from different species, and also it can produce from nature or artificial. So all of these Agarwood have the same function or not? If not, what is different? And how to identify them? So firstly, the chemical composition of the Agarwood we have to clarify first. So come to the second part of the topic is the chemical composition of Agarwood. Firstly, we collect the Agarwood samples from the worldwide. Until now, we have collected more than 100. Here, we are the sample. We store. This is a storage for the sample. And then we started to isolate the chemical composition from them. Here is from different area and from different species, and also from different methods of Agarwood. Because Agarwood have very strong smell, so we usually extract the essential oil first, and then isolate compounds from ethanol extraction. This is a procedure of essential oil extraction and identification. Firstly, make the Agarwood into powder. Here we already make a powder, which will be much easier to extract the composition from the sample. Then we will use steam distillation methods to extract the essential oil. Of course, there are many methods to extract the essential oil. But for us in our laboratory, the most used method is steam distillation. This is steam distillation equipment. I think maybe you already have also in your experimental class. And here, this is a round flask, which used to contain the sample and water. And here, this part is the essential oil collector. And this part here, this part is a condenser. When extract the essential oil, here the flask will be put into a heater. Here we'll put it into a heater. And then the condenser here will connect with the water, running water. Here the water will go from here and come out here. Actually, here inside have a tube, and the water will running outside. When the heater started to heat, the water will boiling in the round flask. And then the steam will go up with the essential oil, will go up from here and go to here. When they arrive to the condenser, here the running water will cool down the steam, which will become water, go back to the collector. So the water here cool down and come back to the collector. Usually, water is heavier than the essential oil, so the water will be stay here below, and the essential oil will stay above. Then, when the water too much to contain in the collector, the water will go back to the flask from the tube. From here, will go back. The water will go back. But the essential oil will always stay in the collector. In this case, essential oil will be collected in this tube. After finish, we can collect the essential oil by open here. Here we can open, and the water and essential oil will come out. So then we can collect them. Actually, we get the water and essential oil together like this. Here, usually below is the water, and here above is essential oil. But anyway, we can very easily to get the essential oil by some liquid extraction with ethyl. Then we send some this essential oil to GC mass, and then identify the chemical compositions. This is the GC mass equipment in our group, in our institute. And from this, we can get here, GC mass chromatography, and then use a database to identify the peaks one by one. And after extracting the essential oil, the residue we will extract with ethanol by the ultrasonic, here to extract the Agarwood again, and then concentrated with rotary evaporation here and concentrated them, and then liquid separation is carried out with petroloid ether, ethyl acetate, and butanol to get different parts with different purity. And then use different column use a different column filled with different materials like ODS, Sevdex LH20, silica, and MIC, as well as HPLC to separate the compound until the pure compound will get. Here, this is the ODS column, and all of this here is the Sevdex. And for HPLC, we usually use analysis HPLC to analysis first, and then use semi-repetitive HPLC to separate them. And the plan structure of the pure compound were identified with different methods, including IR, UV, MS, and NMR. And this is equipment for the LCMS, and this is NMR equipment. And then use optical, and from here we can get some planar structure. And then we use optical rotation, CD, and crystal to determine some absolute configuration. And this is CD equipment. And for some GC mass results of different sample, I will not talk too much here, but I will talk some results of the compound we isolated from the ethanol extractions. Until now, we have worked on 10 different Agarwood here, 10 different, but this name is Chinese name, but later I will talk one by one in English name. And until now, we have published 489 compounds, and the new compound have 204. And we already published 68 papers, and SCI you have 45. And until now, we still continue this work, and so still have some compounds not published yet. And so now let's have a look of the first sample we worked on, which named artificial holding agarwood from Aquilaria sinensis. From the name, we can know that this is produced by artificial method. This method is make a holes here, the holes one by one, the holes make a holes on the stem of the tree. And usually from 1 meter above the ground to start to make the holes. And here usually 15 centimeters to one series of the holes. And this the studies show that so holding produced agarwood have high quality, maybe because fungi here after makes a hole have the fungi inside. The fungi will be very easy to grow in the hole because of the humidity. And in this way, after 2 years, the agarwood can be produced. And after 4 to 5 years, the quality become better. But of course, the time is longer and the quality become better, and the quantity also become more. And this is collected sample after produced the agarwood we collect. And from this sample, we have published 133 compounds, including 66 new compounds. And now I will list the new compounds we isolated from the sample. The first type of compound is this quitopine, which consisted by 15 carbons, usually from 2 isopentenyl groups. Here, this quitopine also have 2 types. One is Adelsman type, like compound 1 to 6, here one group. And the skeleton is consisted by 2 6 membranes, and 2 methyl groups. 2 methyl groups are located at position 5 and position 9. And some group, of course, is oxygenated here, already oxygenated. And this is a type of cis quitopines mostly found from agarwood, especially agarwood from Aquilaria sinensis and Aquilaria malacensis. And another type of cis quitopine is guanine type cis quitopine, like here compound 7 and 8. It is consisted by 5 membrane, and another is 7 membrane. And here very easily to come here consisted oxygen here. This type of cis quitopine also very widely excited in agarwood, and usually cis quitopine have a very good aromatic smell. And the second type of compound is 2,2-phenylethyl chlomos. This compound also very type in agarwood. Later you will find it. And but this compound is very seldom found from other plants. The structure compared to the phloem, there are ether group here. Is a group between the chlomo and the benzene ring. But for the flavonoid, here is don't have this group. And the third part, the third type is 5, 6, 7, 8 tetrahydro 2,2-phenylethyl chlomos. Actually, this structure is similar like before. The only different is here, this ring. Here, this ring is reduction, and usually this pattern is substituted by the hydroxy groups. Here, look, hydroxy groups or the methyl groups. And sometimes also two hydroxy group lose one water to form the oxygen ring. This type also very common to be found in this sample. And from this sample, we also find the 2,2-phenyl ethyl chromome dimers, the dimers. This compound usually consisted by one 2,2-phenyl ethyl chromome and one 5, 6, 7, 8 tetrahydro 2,2-phenyl ethyl chromomes. Here, this is tetrahydro, but this one is normal 2,2-phenyl ethyl chromomes. Actually, this type of compound is very, very difficult to isolate. Only the HPLC can be separated them, but also have to repeat submit to HPLC. As I remember, the first student to isolate this compound is a boy. He is a master student. He almost cried because the sample is really too difficult to isolate. He even afraid he cannot isolate one compound from it and cannot graduate. But later he finally finds as a method, and then isolate a lot of similar compound. And the pure compound usually shows a brown color. According to the linkage here, the linkage between these two parts, they also have several types. The first is with one ether link here. In this picture, all have one ether link here, one ether link to connect these two parts. And usually, these two chromome parts collect two chromome parts here. From some artificial holding Agarwood, we find always the position 8 here. Here's this position 8 at the 5, 6, 7 tetrahydro 2,2-phenyl ethyl chromome connected with the position 6 here, position 6 of the 2,2-phenyl ethyl chromome here from position 8 to position 6. And the second type of dimer, look at here, look at 55 to 60 here. Is two chromome parts connected with two ether linkage here, two ether linkage, and usually a 7 membrane is formed between two structures. The third part of the linkage, look at 61 to 63, it is a compound connected with one ether linkage, one here, one ether linkage, and one carbon-carbon linkage can be connected between chromome part with the benzene part, but also can connect two chromome parts. The last type of compound isolated from the artificial agarwood is consisted by one here 1, 5, 6, 7 tetrahydro 2,2-phenyl ethyl chromomes or the normal chromomes. With another part is phenyl propanoid here. Also here, also. And this type of compound are very seldom. Until now, we only find them from the agarwood. And from for the compound from the artificial Huiqin Agarwood, until now we have published 16 papers. There are a list of the papers. And the second sample we worked is also agarwood from Aquilaria sinensis from the same species. This sample is from Hainan, and this agarwood is a wild agarwood, not like before is from artificial. Until now, we 10 compound isolated from it, and as a new compound, also new compounds, 5, 6, 7, 8 tetrahydro 2,2-phenyl ethyl chromone, and one new here, one new bibenzene compound. And the third sample also a wild agarwood from Aquilaria sinensis, but we call it green agarwood here, green agarwood. The sample, the name green agarwood is actually from the color of the agarwood. Look at the sample. It's not really green, actually still the color, yellow color, like the wood, but on it, on the agarwood, we can see have some yellow color. Green color here, green color. So we call it a green agarwood. And according to the quality, agarwood can be separated to normal agarwood and high quality agarwood. The high quality agarwood, also we named it as Qinan. Its essential oil is much more than the normal agarwood. And according to the color, Qinan agarwood have the white have the name of white agarwood, purple agarwood, yellow agarwood, green agarwood, and black agarwood. Usually, the white agarwood is most expensive on the market. And from this green agarwood, we have published 44 compounds and contain 19 news, including 11 new cis-terpenes and 8 2,2-phenyl ethyl chromones. And this type of the types of new cis-terpene we isolated from the sample, including guanine, like compound 1 to 7, and also acrolein type cis-terpene like compound 8, and also agarwood like compound 9. And also have some hemophilia like compound 10 and 11. In the structures of guanine type cis-terpene, the oxygen here, oxygen ring formed between position 5 and position 11. This is very type of this compound from agarwood from the Aquilaria sinensis. Here 1 to 5 also compound we all have this oxygen ring. And agarwood type cis-terpene like here, this compound 9. Is also until now only find from agarwood from Aquilaria sinensis and Aquilaria agarwood. So this is also very type compound. In addition, here 6 new 2,2-phenyl ethyl chromones were isolated from this sample, as well as 1 2,2-phenyl ethyl chromone glucosidone here connected with one glucosidone sugar. And this is the only compound until now find from Agarwood. And the last compound here is a dimer consisted by 1,2,5,6,7,8 tetrahydro to 2-phenylethyl chromosome and one guanine type 6 being. From this sample, we only find one for the dimer of the chromosome and the cis-being. And from this sample, we have published 8 papers. And the first sample was Chonglou Agarwood. From the same species, Aquilaria sinensis. Chonglou here is a Chinese name. Chonglou means this agar was chong, is insects. Chonglou means produced by this agarwood is stream by the insects. And this is a kind of wild agarwood produced after woody tissue of trees eroded by various insects and accompanied with a different response of the plant itself. Chonglou agarwood is recognized as one of the high-quality natural agarwood. From this sample, we have published 12 compounds, including 3 new 2,2-phenylethyl chromosomes. Here, this is an X-ray crystallization analysis of compound 1, and this compound 3 is a chloro substituted compound. Here, and we use ECD calculation to determine the absolute configuration. And from this sample, we find very interesting was that all of the structures featured 5 position here. 5 position is and is substituted or chloride, substituted. Here only 3 new compound, but actually we have also some no compound. But all of the compound, all of the chromosomes isolated from this sample have this character. So this is very rare, very seldom reported from Agarwood. And all this type of compound until now only less than 20 reported. Therefore, it is probably to be a chemical characteristic for Chonglou Agarwood. But for the chemical composition studies still necessary to determine to say this result. And the 5th sample is agarwood from another species, is from Aquilaria classna, which was collected in Laos in September 2004. 2004. From this sample, we have published 70 compounds, including 28 news. From this sample, the most type of compounds we find is also cis-beans and 2,2-phenylethyl chromosomes. But different from adult man type cis-bean find from the Aquilaria sinensis, especially from the artificial agarwood. The new cis-beans we find from this sample is Aromophila cis-bean, like compound 2 to 5. The structure different from adult man type cis-bean is the position of this methyl group. From before position 9, now move to position 10. Anyway, man type cis-bean also could be isolated from this sample. And compound 1 is a cardinal type cis-cutopine, just the cysteine here. Cysteine lose hydrogens to form three double bonds and form benzene ring. And compound 6 to 10 or 2 phenyl ethyl chlomos, and 11 to 13 are also 5, 6, 7, 8 tetrahydro to 2 phenyl ethyl chlomos. And similar to previously, the dimer also isolated from this sample. The linkages here are also similar like before, with 1 ether linkager or 2 ether linkager, or with 1 ether linkager and 1 carbon-carbon linkager. The style is the linkage is very similar. But one special dimer found from this sample is compound 14 here, this compound, with 2 phenyl ethyl chromo consisted the dimer, because usually one is 5, 6, 7 tetrahydro, another is a normal chromo, but this one is 2 chromos. And from this sample, another special type of compound is this license. The dimer consisted by 1, 5, 6, 7, 8 tetrahydro to phenyl ethyl chromo here, and with cis-cutopine. This is the first time to find this type of compound from Agarwood. Before also have one, but cis-cutopine is different. And then and also before we only have one compound with chromo and cis-cutopine, but from this sample we have the number the number is very high. And from this sample, all of this compound find the linkage, the position is the position 8 of the chromo connected to the carbonyl group on the cis-cutopine, like here, or in position 8 here from the chromo and connected to the cis-cutopine. And here are the publications from Agarwood, from Aquilaria class now, from Laws. Totally we have 12. And the 6th sample is also from Aquilaria class now. We published 40 compounds, including 9. And this sample is from Cambodia. Yes, the place is different. So, but all the species is the same. And from there are 6 new compounds. There are 9 new compounds. And the structures are very close from the Agarwood, from the Aquilaria class, from the Laws. Just the 5, 6, 7, 8 tetrahydro to phenyl ethyl chromo, and the cis-cutopine dimer find connected with here, position 5 here. From this sample, the dimer always the position 5 of the chromo to connect with cis-cutopine. And also here, the 3-member oxygen ring excited in the structure, and this is very is not found before. So it means maybe some general compound is the structure are the same, but have still some minority structure different from between the different place of the Agarwood. And this is the publications. And the 7th sample. The 7th sample is also originated from Aquilaria classna, but this is from Vietnam, also from different countries. But Here, the procedure of the production is very special. We call it red soil agarwood, not just the agarwood. From the name of red soil agarwood, we can know it is related to the red soil. Actually, this is produced when the trees buried in the red soil for a very long time. And it is mainly produced in Vietnam. And in other places, it's very seldom to find. And the red soil agarwood in Vietnam is very special. Is especially only from formed from the Aquilaria clasna. Because this in one place, in one city, here very on the mountain, a lot of Aquilaria clasna trees before, but for the war, the Vietnam war, and also a lot of trees fall down and buried to some red soil, and then until now, some red soil agarwood produced. And this agarwood is also very important agarwood in the world market. It has a red surface, diamond red surface, with a purple and brown heart. The heart is purple and brown. While the oil distribution is also very obviously from some sample. The oil distribution can be very clearly found. And the smell of this sample have a slight fragrance with ink aroma. And from this sample until now, we have published 37 compounds and including 7 news. Here, 7 new compounds were 5, 6, 7, 8 tetrahydro to 2 phenyl ether chromo derivatives. And the special of this sample is here, some the relative configuration of the tetrahydro chromo pattern. This relative configuration is very abundant find from this sample, but not so much find from other agarwood. And here are the papers we published. And the 8th sample is agarwood from Aquilaria wala. This is also another species. Wala is recorded mainly distributed in the wet and intermediate zones of Sri Lanka, and a minority in southwest India. Its agarwood appears usually black with small white spots and has unique cool fragrance. So the smell of from Wala agarwood is also different from other agarwood. And until now, we published 60 compounds. From this sample, 22 precision type ciscotobin were isolated here. All of these ciscotobins, and the structures are consisted by a 5 membrane and a 6 membrane. This type of ciscotobin is not so common in the nature. Until now, only this sample and Aquilaria melanosis have been reported. And there are also some other type of ciscotobin and also totophenyl ethyl chromo derivatives isolated from this sample. And here are 7 dimers, and the absolute configuration were already determined by this picture. And compound 1 and 2, they are different from others. They are connected with 5,6,7,8 tetrahydro 2,2-phenylchromose, and with one flavonoid here, flavonoid. This is flavonoid, and this is 2,2-phenylethyl-chromose. Until now, totally only 3 this kind of dimer have been reported from this sample, and none of them have been reported from agarwood from other species so far. And flavonoids are widely distributed in different parts of Aquilaria plants. Later, I will show it. While the dominant aromatic compounds in agarwood 2,2-phenylethyl-chromone derivatives. So the formation of flavonoid 2,2-phenylethyl-chromone derivatives may be during the agarwood producing stage, but also probably related to evolution of the plant species. Actually, until now, we also find some this kind of cyclopine connected with chromome is a dimer, but until now, because we haven't published, so I didn't show in this point. This is also very special, a kind of very special structure. And until now, we have published 8 papers. And the ninth sample is agarwood from Aquilaria filaria. This is from Indonesia in 2017. It is mainly also distributed in Indonesia, in Philippines, and Papua New Guinea. From this sample, we have already published 59 compounds, including 18 new ones. Here are published new compounds, including 4 guanine type cyclopines and some 2,2-phenylethyl-chromose and compound 7. Here is a special structure which had sulfide here, the bone here, this group. And here are the papers. And the last sample is agarwood from Geranopus salicifolia from Papua New Guinea. And this is actually here, this is another genus of plant which can produce agarwood. Most of agarwood we get is from Aquilaria species, but from this species we also it also can produce some agarwood. And from this sample we have published 40 compounds, including 15 news. Here are the new compound. The structures actually from the structure we can find they are very close to the compound from Aquilaria species. So from different species, but the structure types is still very close for the agarwood. And here are the publications. And because of abundant work on the chemical composition from agarwood, so we also invited to be write a review about agarwood on Natural Product Reports in 2020. Not only the chemical structures, we actually also study the bioactivities of the compounds and find some is very interesting, have a very interesting bioactive structure. And one of them we are synthesis the structure now. And by studying, we already know that the cyclopines and 2,2-phenylethyl-chromose are 2 main chemical composition in agarwood. But how about the chemical composition in the Aquilaria plants? Which means what kind of compound in this white in this white of the trees. So look at these two pictures. This is before Agarwood produced, and then here the black part is Agarwood. So are they have the same chemical composition or not? So we also review the publications and conclude the compound from Agarwood plants. And they are mainly have the structures as below. So here first is flavonoids. Flavonoids have the most from the Agarwood plants. And the second type is benzophenols. And the third is xanthones. And the fourth also have reported 10 2,2-phenyl ethyl chlomos from the Agarwood plants. But actually, we guess the number from here is not so much. But from the Agarwood, this type of compound is very common. So we guess maybe this plant already started to produce Agarwood. And then also we isolated this compound. And also have some ligands, and also have some simple phenolic compounds. And from the plant also have reported cisquiterpenes, and but cisquiterpene you can find fairly different from the structures find from Agarwood, and most of them they are connected with sugar. But from Agarwood, we cannot find this kind of structure, and also have the ditopenoids, and also triterpenes, and steroids, and alkaloids. So from this structure, we can find actually the compound from Agarwood and from the trees are very different. From the trees, the types is more variety, but from the Agarwood, the main compound is cisquiterpene and 2,2-phenyl ethyl chlomos. And I will also here talk some other work for other research on the Agarwood. And in addition to the chemical composition from the Agarwood, we also genomic sequence of the Agarwood tree, Aquilaria sinensis, because in Hainan we mainly have the Aquilaria sinensis. So we genomic sequence of this plant. And this part we also as the first group to publish this results. And we also make the Agarwood inducing reagent, because Agarwood only produce when the trees are hurted, and it takes a very long time to produce, usually around 10 years can be collected. And the Agarwood produced usually not so much, because the injury part of the trees is limited in the nature. Now we use this reagent to induce the trees to produce Agarwood. Look at this picture. It can make the whole tree here, the whole tree to produce Agarwood. So the whole tree already, the color already changed. And meanwhile, shortest time to 4 to 5 years can collect them. We already get us a patent for this is a patent for this reagent, and also use it in Guangdong, Hainan of China, as well as in Thailand, Laos, and Malaysia for this reagent. And then we also develop Agarwood essential oil here, because before in some company, the essential oil after extract them, the smell is not so good. Then we try to develop it. According to the chemical composition of agarwood, we already find that cis-quinidine and totophenylethyl are two main compounds. After we isolate the compounds, we find some of them have smell. For example, the first compound here, first compound shows the core and reflection and have honey-like aroma. And all of these compounds have different smell here. And these two compounds is also find from the essential oil, and they have very high quantity, and also can have the smell. And according to this, we modified the extract modified method to extract the oil, and then now the smell of the agarwood essential oil become very nice. And for the two aromatic here for these two phenylethyl and have the smell. Actually, we find the quantity is very high, especially in the high quality agarwood. I mentioned before that the high quality agarwood, we also call it Qinan agarwood, but in the normal agarwood, the quantity of these two compounds is not so high. So we now use the quantity of these two compounds to identify this agarwood is Qinan or not. These two compounds after fire here. This is GC mass result from Qinan agarwood. Look at the quantity. Is very high here. Almost these two compounds totally have more than 60. And actually, these two compounds after the fire, they give more smell than these quinidines. And then now we also we already know that the normal quality agarwood and high quality agarwood, and high quality agarwood we call Qinan. Actually, we find that Qinan produced related to the variety of the trees. Some of Aquilaria sinensis can produce Qinan agarwood, but some just produce normal agarwood. So we, according to the genome sequence of Aquilaria sinensis and also the chemical composition difference between the normal agarwood and the Qinan, until now we have developed 6 different varieties, and not only all of them can produce Qinan agarwood, but also reduce the time to produce. For example, number 2 here this is produced from number 2 trees. Can harvest the agarwood at 4 years. So after 4 years, we can collect the agarwood much shorter the time than nature trees. Here are the license we get for the new varieties of agarwood trees. And now look, number 2 agarwood trees have widely planted in Guangdong, Guangxi, Hainan, Yunnan, and Fujian. And in Hainan have planted 20 to 30,000 acres. And Guangdong is also the same. And also Guangxi is 30 to 40,000 acres. And now the first part I will introduce is the outcome from studies of agarwood. Until now, we have compiled 4 agarwood books. And also because the agarwood is very expensive in the market. So there are a lot of fake agarwood. And according to the chemical compositions of agarwood, we make some methods to identify the agarwood. And we set the identification standard of agarwood and also the quality grade standard of agarwood. And they also have been accepted by the government, and now we already get the license from the government to identify agarwood in our institute. So here, this means this is an identifying center for agarwood. And also, according to the chemical composition and the bioactivities, we use agarwood to develop a series of products, including essential oil. Here, essential oil, perform. Here, this is perform, and here, juice sticks, and so on. And some of them are very welcome by the market. And in the end, I will introduce my Institute of Tropical Bioscience and Biotechnology, Chinese Academy of Tropical Agriculture Science. So here is our main building of our academy. And for my group, we now focus on the studying the tropical medicinal plants, especially Li folk medicine in Hainan. And this is our lab, and this is for the chemical lab, and here also rotary, and here we usually put as a column, and this is our student, and this student is from Nigeria. And this is public instrument lab, like CD, GCMAS, or in this lab. And this is one of HPLC lab. Actually, we have two. And now we already have 3 analysis HPLC and 5 semi-predictive HPLC. And this is LCMS. And this is 500 hertz anima. Actually, this year we already also bought another 600 hertz anima, but and we'll start to use very soon. And this is a molecular lab. So thank you very much, and welcome to China, and welcome to Hainan. Thank you.
Thank you very much, Dr. Huiqin Chen. What amazing work! I can imagine how hard work behind these results. Yeah, actually, I have plenty of questions.
I didn't understand. Yeah, of course. Please.
I would like to come to Hainan one day.
Yeah, of course. Welcome.
Okay, now all participants, we come to the second session, which is discussion. And please write your question in chat, or you can directly ask to Dr. Huiqin Chen. So I see here from meeting chat, Dr. Antonius Ola. How are you?
I'm fine, thank you.
Tony,
Yeah.
nice to meet you.
Nice to meet you, Dr. Huiqin.
Yeah, it's so long time.
Yes, so long. That's why I have to let everything out and focus on your talk, Huiqin.
No problem.
Yes, please, Dr. Ola, you're first.
Yeah, Huiqin, your work is very great, Huiqin. I think this is better than Dusseldorf.
That's right.
Yeah, this is very good work, very great. This is great, Huiqin. Yeah, maybe one day you can work also with Trini and ask about the Agarwood or something else. But anyway,
yes,
I
please
just
make
have
collaboration.
Yeah, of course. Yeah, actually we have the cooperation. also with different countries for the agarwood. Now in Thailand, in Laos, we all have the cooperation. Yeah.
All right, thank you, Huiqin. Huiqin, yeah, I just have one question. That's very great work, many things to ask, but anyway, I already put the question, but then you give the answer later. The difference in smell, the difference in smell
Okay.
between two ethyl phenylchromone and then the Susky terpenes. Which one is better, or they are all very nice?
Okay. So I will look at this question. Yeah. Thank you, Tony. It's all. Yeah. Actually, chromone metabolized. Actually, is usually for the naturally the smell. Until now, the knowledge. Until now, we get the knowledge. But later maybe we find some other information. But until now, we find the smell from the nature agarwood is mainly from the cisquitobin, but like these two compound, I will show you here have these two these two structures, the chromome.
Yeah, the two chromone, right? The last one.
I will show you these two chromome. Here. Can you see me?
Yes, I can see. Yes.
Two structure. Actually, we also get us a pure compound already. These two compounds have smell. Yeah, have smell. And then, as we know, actually after fire some agarwood, because in some ceremony or some religions also use agarwood to fire, as you know. So it's from the smell, actually, the chromone also play very important have the smell very good. And the long the smell very long time is from the chromone also.
I see.
Yeah.
That's great, Huiqin. That's great. That's very great, Huiqin. Normally people only know about the sesquiterpenes, but then you found out chromone that also give the difference.
Yeah. Actually, the chromone we already isolated a lot, and for the another type for 5, 6, 7, 8 tetrahydral chromone, but that kind of chromone usually don't have the smell, but this kind of yes. And also, actually, we do experiment from the agarwood to start from the because it produced when the tree is hurted. So when hurt the tree, we every month we get the sample and we find from the sample the chromos, the structure of the chromos in the agarwood is different. So it means during the process of the agarwood, the structure of the chromose is produced, and also the structure is changed during the time, according to the time.
Okay.
Yeah, it's very interesting.
Oh, but thank you very much, Huiqin. That's very, very nice work, Huiqin.
Thank you, Tony. I hope sometime maybe later we can have the chance to really to sit together and to talk each other face to face.
We can also invite Trini together. Maybe Excalibrus or something else somewhere.
Thank you.
Yeah.
Thank you, Dr. Ola. So
Thank you.
it means this simple phenylethylchromone actually the one that played the role for the smell, right, Huiqin? Dr. Chen?
Yeah.
These two simple chromone, phenylethylchromone, without any chiral things like that, are the main role to give the smell.
You mean I can
the previous phenylethylchromone that you show us the previous slide, they whether they are dimer or they have tetrahydroxyl groups in the ring, right?
Yeah.
But actually, the one who give a very nice smell and long-term smell is these two compounds.
Not
Aren't
only
they?
not only these two compound. Actually, for after fire, maybe some other other chromos also can give the smell. But these two compound for the naturally also can give the smell.
Oh, okay.
But after the fire, some other chromo also maybe can give the smell.
Okay, after burning the agarwood, do you mean?
Yeah.
Okay, all right. Thank you for the clarification. So, is there any participant? I saw Rizka who raised hand before. Rizka, are you there? Rizka? Did you raise your hand, Rizka Ramadhani? Okay, another one is Seti. She asks in Indonesian. I will read first, Huiqin, and then I will translate. Oke, Seti. Di Cina sangat banyak sekali obat tradisional. Apakah terdapat kandungan agarwood di dalam obat tradisional yang ada di Cina? Jika ada obat yang mengandung agarwood, apakah manfaat dari obat tersebut? Okay. So, Dr. Chen, there is a student here is asking you.
Yeah.
She said, I am Seti Tiara from Universitas Tanjung Pura. Would like to ask question. In China, there are lots of traditional medicine. Is there any agarwood contained in the traditional medicine in China? And whether this medicine, which contain agarwood, what is the use of it?
Oh, okay. Yeah. Actually, now in one of hospital, we have the cooperation. We use the agarwood to for some disease from the stomach, for the stomach. If you have some stomach pain or have some problem from the stomach, then have one of Chinese medicine means named 沉香和胃丸 and you use this medicine, so contains agarwood, and after you take it, so you use this medicine to cure the disease from the stomach. And also here, for example, this picture here is named 沉香疏玉丸. 沉香means agarwood. So in this medicine also have the agarwood inside, and also actually for ourselves sometimes you know, Professor Dai, he is a group leader of us, and also actually he is really he is really professional in agarwood. So sometimes he suggested us, because for me, sometimes I have some problem for the stomach. So before he give me one piece of agarwood, he said, you can put this agarwood into the water and then drink the agarwood water. The pain, the stomach pain will be relieved. So actually, this is very good for stomach. This is one way. Another is, for example, for them, because now our modern life is very quickly, and sometimes get nervous. So for the agarwood to burn the agarwood, but anyway, not just the agarwood. We have the agarwood products. For example, for the jaws stick, like this. I will show you here for this products. When you burn this agarwood, so you will become relax, and you will sleep well, like this. So you will feel relaxed, more relaxed, and you can go to sleep well. Sometimes you have some problem from the sleep, so you can find agarwood here. Okay.
Okay, thank you, Dr. Chen. Well, Seti, is it answer your question? Seti, do you need me to translate? Okay. She answered, iya bu. Iya bu means yes, ma'am. Okay. Thank you for the answer. Okay, thank you, Seti, for the question. Okay, another question from Rosalia Colina.
Yeah.
It is in Indonesian. Wait a second, I'm going to read it. Okay. Rosalia asks you, Dr. Chen, what she knew that agarwood can be harvested, the essential oil, after 3 or 4 years. But before that, whether the essential of agarwood can also contain different compounds, or only the rendement is different.
Is it asked the essential oil? It means from different time of the agarwood. So the essential.
That's right. That's right.
Oh, yeah,
Whether
okay.
the essential oil contained in agarwood is different between after 3-4 years, or just the amount is different.
Yeah, I think perhaps different, because some chemical composition in the agarwood is different from according to the time. For the first sample, actually here I showed the first sample is an artificial agarwood. From here, the compound is actually have some different from some wild agarwood. It's different actually for us. We think just because of the time, because artificial agarwood grows shorter time, and the wild agarwood grows longer time. So the composition inside have a little different. We have some different. But if the artificial agarwood if grow long enough, so they also will have some. The same composition. So it means in the agarwood, with the main compounds are scopolamine and chromium, but some still have some different structure in between during the agarwood production. So it means when you get the agarwood from different time, for example, 3 to 4 years or 10 years, some compound in the agarwood is different. So when we extract the essential oil, we also can get some different compounds. Contain the essential oil will also contain some different compound. But anyway, because And most of the of them is from in the essential oil is ciscotobin and also some very simple simple structure of chromo, but not the dimers. So so it made so there's a made compound is still the same, but have some small different inside. And
Okay.
and also actually for the Qinan Agarwood, Qinan is a high quality Agarwood, and also compared to the normal Agarwood, there is essential oil between them. They are different. And Qinan, even Qinan Agarwood, grow short time. The compound for these two chromo compounds containing also very high, but for the normal normal agarwood, says even long time, but the quality is still very still lower. So in this case, we can say it's a different time. The major compound should be similar, but you have some smaller different. Yeah.
Thank you, Dr. Chen. Well, what about that, Rosalia? Apakah sudah dimengerti jawabannya?
Izin Bu,
Ya.
boleh saya menyimpulkan Bu supaya tidak salah.
Who is this?
Berarti kalau misalnya berbeda waktunya itu juga mempengaruhi itunya ya Bu, komposisi senyawanya.
Ya, ya. Kalau berbeda waktunya, komposisinya akan berbeda, tapi berbedanya sedikit. Lebih kompleks, tetapi komponen utamanya menjadi lebih tinggi kualitasnya. Ya, tadi yang diterangkan oleh Dr. Chen itu adalah untuk senyawa-senyawa utama nih, kalau untuk agarwood yang berkualitas tinggi, maka dia komponen tersebut akan memiliki konsentrasi yang sangat besar, gitu ya. Walaupun nanti ada senyawa-senyawa minor akan muncul gitu, kalau waktunya semakin panjang, gitu Gerina. Ya. Any question? Okay. One question from me, Dr. Chen.
Yeah.
It is interesting that agarwood is produced by this kind of plant. So what happened with that plant actually when agarwood produced?
Yeah. This is a very good question. Actually, now we want to know, and there are two different arguments in the researchers. One is said when the agarwood, when the trees was hurt, so the fungi the fungi will grow, and this fungi to produce the agarwood. And another argument is that this is produced by the agarwood itself. So it means when the trees was hurted, so the trees itself want to protect itself, then active some journals, and then to produce the agarwood. So until now, actually, we are also already started to study this part. We isolated the fungi from the agarwood, and then use this fungi to culture with the white wood, and we want to see if it can grow the agarwood, but not the result not really come out yet. But anyway, until now, the most accepted accepted is it is said agarwood is produced from both induced one is fungi and another is the plant itself. and also some of fungi already also have some reports said some fungi is very is helpful for the trees to grow fungi. And now recently we actually in the laboratory already grow already have some fungi, and in the tree we cut the wood and and then put this fungi onto the tree and to have a look if the agarwood will grow much quickly. So actually for this question I can't answer very well. Just now have some argue on this question. Yeah. Yeah.
That's why the research is start, right?
Yeah. And now we in Hainan we have two groups mainly work on agarwood, and another group also they are studying this question, and now we also have some cooperation and want to solve it, but actually it's not so easy.
So when agarwood, after agarwood is harvested from the plant, can the plant be hurt again to produce another agarwood, or the plant will stop to produce?
Actually, when, for example, because agarwood have some when you for example hurt agarwood one place, so only around this hurt will grow agarwood, but the other place will not. So wood is still white, but only around this place already hurted can grow the agarwood. So when you cut another place, so another place also will grow agarwood. So that's why we now use this reagent. This reagent will go to the whole body of the stem, and then the whole body of the whole stem of the trees will grow the agarwood. So the quantity will be much higher than from nature.
Oh, great.
Yeah.
And
Because,
after that, we can produce again agarwood when we already harvested, and then we can induce the plant again with the reagent, and the plant will produce again agarwood like that.
Yeah.
It will continue. There is
yeah.
a continuation to produce agarwood.
But the problem is when you collect the agarwood, actually you have to cut the trees.
I see.
Even the trees not die, so of course continue to grow. Yeah. But the trees already cut it, so not grow again. Yeah.
Maybe only cut half, Huiqin. We just cut half and then let the rest.
Yeah. Now we in another place we have agarwood garden, and then we use different reagent and different way to try to have a look how to produce more agarwood.
Okay.
Yeah.
Yeah, actually in Dr. Ola's place, there are plenty of agarwood there, isn't it?
Sorry?
Yeah.
In Dr. Ola's place, there are plenty agarwood plants there.
Oh yes,
Yeah.
Yes. We also have that one, but yeah, the agarwood and then the sandalwood. Santalum album. It's the same thing. Like you need to wait for some years to harvest the tree. Yeah, but it also has fragrance like agarwood.
Oh, okay.
Yeah. So maybe like your reagent is very important. We can try also with other plants. Who
We need to
knows?
buy it.
Yeah. Actually, we also sell the Agarwood trees now.
Oh, great.
Really?
And,
Already, because we have the small trees, and as I mentioned in this PPT, we have some different varieties of the agarwood. So this agarwood is mainly to produce Qinan agarwood, so it's a high quality agarwood. So now we sell.
Oh, that's great. Maybe I need that one, Huiqin. We can try.
Yeah.
We can try to go in other place to see what is the difference.
Yeah, of course. Yes, of course. Yeah.
So what do you say about agarwood from Indonesia, from Aquilaria plants from Indonesia, Huiqin? Because you mentioned that there are Aquilaria becariana, for example, Kumiana that from Indonesia, and Filaria from Indonesia. Do they different, or they're not as good as another agarwood plants, or
This is
how are they?
Another agarwood plant, different species from the Aquilaria genus. So because in different countries have the different species of Aquilaria trees. So in Indonesia, mainly the local plant is Aquilaria filaria. And in China, we have main the local plant is Aquilaria sinensis and Aquilaria unanis. So this is different species, but all of these species can produce agarwood.
Yeah. Okay. Dr. Chen, there is a question in chat.
Yeah.
It is in English. You can read it as well. From Sharifah Nur Intan Mutiara. She would like to ask you one question. What the most difficult step that you did in this research?
Sorry, what's the...
What the most difficult step? It is in the chat. You can read it. What is the most difficult step that you did in this research?
So most of the difficult for the compound isolation is to isolate the chromodimers. For the chromodimers, is really difficult to isolate, especially for the student. Actually, now the student already knows the method to isolate, so not so easy anymore. But at the beginning, the first student, as you know, the first student is a boy, a master student, a boy. He really cried, you know. So, as I remember, in the evening, and he cried to me. He said, "How can I do? I cannot get the compound, and I cannot graduate." And he cries the whole evening. And then I encouraged him. I said, we will ask different teachers, and we can try. And then after some time, and then finally he finds some method to separate it. But anyway, it still have some fractions. It's still very difficult because this kind of compound is too much. So the compound is a lot inside, and different compound, and the quantity for the for example, one compound, the quantity for one compound is very small, only maybe several milligram, but the compound is really too much. And from the HPLC, you cannot see the peak. Almost you cannot see the peak. Only like a mountain, a hill. So And really,
Oh.
it's not a pick one by pick.
So we
Just
cannot
like one mountain.
separation there. Yeah.
Yeah. It's really difficult to separate.
Oh.
One injection. Sometimes just one injection, you have to waiting for more than 1 hour. So and then you have to repeat to submit to the HPLC and to collect the pick. And then finally he find, and we also use different column for the HPLC for carbon 8 and also
18.
carbon 18 and also some other material for the HPLC column and also different solvent. And then finally he find and isolated the compound. And until now, now the student they can follow some procedure, so they will much easily. Also now we from the HPLC, from the UV, the different dimers. For example, the dimer for the chromo dimer or for the chromo and the cis-cutubine dimer, the UV is different. And then according to the UV, we isolate different kind of compound, and also from the usually before go to before separation, we use LCMS to have a look maybe which part is the dimer and which part maybe the dimer of chromo and chromo or chromo with cis-cutubine, and then to according to the structure, and then isolate the compound. Yeah.
Great. Is he happy now?
No, he already graduated, and actually he already finished his PhD this year.
Oh, great.
Oh, that's great. Oh,
He already
congratulations.
have PhD.
Congratulations.
Yes, and he actually after the master, because he published two SCI and he went to another university for the PhD study, and then this year he already graduated, and he already also find a job. Position in another university, already started work.
Oh, wow, that's great, Huiqin.
Yeah, and
nice.
it's very happy.
Oh, you are a great teacher, Dr. Chen.
Thank you, really.
You produce a PhD.
Actually, he is now the student is Professor Dai's student, but because when I come here, he follow me for the experiment. So yeah.
Yeah, that's great, Huiqin.
That's great.
Yeah. When I see your compounds, like they are similar structure, maybe only different in one carbon, the different stereochemistry in one carbon. So I already think how hard is the isolation process.
That's right.
Yeah.
That's
And
right.
also the number is too much.
Too much, yeah,
Yes.
Huiqin,
It's too complex.
It's too complex,
For one
Yes.
signal, it's too complex.
Yes, that's true. Yeah.
It should be very close each other.
Yeah, very close. Like a mountain, really mountain. Really, not a pig, just the mountain. And they usually have the color. Yes, this kind of compound. Color. Yeah. Have the brown, usually brown color. Yeah.
Oh, great. Okay.
And now another student, master student, now is working on the Wala, Agarwood. Now also follow me. This student until now isolated a lot of the dimer for the cis-cutubine and chromo, and for her, she also isolated more than 30 new compounds already.
Whoa.
Yeah.
Wow, Huiqin, yeah.
And also one compound, one of chromo compound with 8,5 hydroxide. this compound, the bioactivity is very good. And for the anti-inflammatory, it's really good. So we now synthesis this compound, and want to do more bioactivities. Yeah.
Yeah. I remember you would like to speak as well about bioactivity, right, Dr. Chen?
Yeah.
But
Actually,
maybe
we now,
another session.
yeah. Actually, we now want to work more on the bioactivities because we want to know how to use this compound, not just the isolated compound. Yeah. As we just isolate compound actually is no use, just the new compound. Okay, just the publish your paper. So after the publication, just throw away and we put us aside. But we want to know how to use because we have so many compounds, and we also use this compound because we now already several hundreds of compounds from Agarwood. So now we use this compound to identify. For example, we get up agarwood from different species from different places, and then we have a database for all of this compound, and then we get this sample and you use this database and to identify this sample directly from which species and from where. So now this database we are building now. Yeah.
Oh yeah, I remember one thing, Dr. Chen.
Yeah.
Previously, there is one compound, one or two. In this compound, there is a chlor group. Chlor. A chlor group. Yeah. Attached to the ring.
Yeah.
Where does this group actually come from?
This is before actually when we published submitted this paper, some reviewer also asked maybe this compound come from the from artificial maybe. But actually, we are still think this compound from nature. Also maybe sometimes, but from this sample is from wild. So until now, I'm also cannot say very clearly because from the artificial, we also didn't find. But for the chloride, some compound, until now we isolated maybe have several of them, not so much, but also because this is one new, but some also no compound with chloride, and maybe this is just related to some maybe sediment in the trees or somewhere else, but I'm not so sure. But we still think this is not from artificial, but from
nature.
Oh yeah.
From the soil itself.
Yeah, maybe. Yeah.
Because when you compare with the nature, compare with the aqualaria plants, you also show that there are 4 compounds that also have this chloride group inside, right?
Yes.
But normally only from marine plant or marine ecosystem that can produce this kind of compound. So I thought maybe because of the soil, or maybe because this land previously years ago was on the ocean and so on.
Yeah,
that's
maybe.
why there is this chloride group.
Yeah, that's probably. Yeah. Also, maybe, probably, maybe.
Okay. Come back to the audience. The participant, is there any question still to Dr. Chen? Okay, Gerina.
Izin Bu, I will ask you about a little different topic. Can I?
Yeah, of course.
About when you describe my question before, you describe about artificial Agarwood. I kind of interesting about that. Can you a little describe about this topic? I think maybe different plant can make artificial, or just Agarwood can be artificial. Are you understand my question?
Not so clear.
Okay.
Gerina, you can speak Indonesia and
Oke, gini Bu, tadi kan Ibunya menjelaskan tentang artificial agarwood. Nah, saya tuh baru dengar tentang artificial agarwood. Jadi tuh apakah tanaman lain tuh bisa dibuat artificialnya juga, dan juga tadi itu juga menjelaskan artificial agarwood ini menghasilkan komposisinya tuh sedikit karena waktunya yang sebentar. Apakah bisa dibuat artificial yang juga menghasilkan komposisi agarwood dalam waktu yang lama, kan tadi lebih banyak dan bervariasi gitu. Terima kasih.
Ya. Artifisial yang dimaksud di sini tadi itu Gerina, jadi tumbuhannya itu dilukai oleh manusia gitu ya, bukan oleh alam. Jadi dilukai oleh manusia sehingga dengan terpaksa tumbuhan itu menghasilkan agarwood. Itu maksudnya. Ya.
Terima kasih.
So, Dr. Chen,
Yeah.
Gerina asked you about artificial agarwood. She would like a more detailed explanation about artificial agarwood itself.
Artificial.
Artificial.
Oh, artificial agarwood.
That's right.
Okay. Artificial agarwood. So it means you want to know how to some detail about the artificial agarwood. Yeah. Artificial agarwood have several ways. Now here I introduce the first sample. The artificial agarwood is from the holding, so it means makes a hole on the stem. So usually from the 1 meter above the ground to make the hole around the stem. So makes a hole. I will show you the picture. Can you see the picture? Can you see the picture?
Yes,
Yes, we can see.
Yeah. So this one is for the holding agarwood. So it means makes a hole on the stem, and then usually after 1 meter above the stem to start the hole, and every centimeters. Here, every 50 centimeters, and to make one series of hole. So here, like this. So in this case, the tree will produce the agarwood. So this is one way. Another is here. I also showed. This is use liquid reagent. So here. Yeah. So here, this is agarwood induced reagent. So in this bag here, can you see this bag? This is green bag.
Yes.
So
we see.
This green bag have the reagent. We put it inside, and then like some and here this person have some. This is a tuber. This is a tuber. So the liquid will come out from this tuber, and here have a needle. Some needle can put inside to the trees. So the liquid can from this bag come out from this tuber and through this needle. and then go to this plant. And in this plant, the reagent go to this plant, and then because because usually this one used in the sunny day, because it's a sunny day, the trees will breathe very stronger. So the water will go from the roots, or we can say from the stem. The water go up. So the water inside to go up. So it means the reagent from after go inside to the stem, and then go up to the stem. So the whole, but usually also 1 meter here, every 1 meter to put one
Every
bag.
1 meter.
Yeah. So because the whole tree only 1 bag is not enough. So every 1 meter, so put usually 3 bags. 3 bags every 1 meter, and then for this part will fall with reagent. Then after stimulated by the reagent for this part, so will grow the agarwood. So after some time like this, the whole tree will grow the agarwood. So this is the second time now we use very widely. And also the second time now is here I don't have the picture, is cut the trees, cut. After cut it, and then we spray some fungi inside to put to spray the fungi to the place of the cutting place, and then this place will grow fungi, grow agarwood. Yeah. So it means for and before, very a long time before, people just use oxen to cut it, to cut the agarwood. So it means just make the trees hurt it. So it's a place will grow agarwood. So this is artificial agarwood. So it means produced by the influence of people. Yeah.
Thank you, Dr. Chen. I think, do you understand, Garina? Is it answer your question? Yeah. Yeah. Dr. Chen, there is a last question here from, there are another question.
Yeah, please.
From Mrs. Ira Lestari. Would you share to us again how to extracted and isolated the compounds from agarwood? And what technique or strategies or solvents that you applied before the best for isolated the compounds? Thank you. This is the question. It is in the chat.
It means the solvent used to an equivalent to use to isolate the compound.
Yeah, how to extract and to isolate the compounds from agarwood, and what kind of technique or strategies or solvents that you applied, and which best solvent to do that.
Oh, okay. So for isolated compound, so usually we use ethanol to extract the agarwood, and use sonicer. Use sonic and to sonic the agarwood. Here use ethanol, and then because ethanol usually can. The polarity is not so low, it's a little high. So it uses the ethanol. It usually can extract most of the compound from agarwood, and then use a rotary to evaporate, and then we from here we can get us get us a sample, and then this sample dissolve in the water. and then use liquid separation. Usually we use petroloid ether, and then acyl acetate, and then butanol. So this three solvent, because the polarity of these three solvent is very different. So petroloid ether, the polarity is lowest. So can extract some compound like cis-quaterpine, and then use acyl acetate to extract some middle polarity compound. Usually some chrome usually in this part of in this part, and then butanol also used to extract. But for agarwood, actually, according to the experience for the butanol part, the sample is not so much, because most of them, most of the compound, the main compound is cis-quaterpine and chrome in the agarwood. So they usually go to the they are belong to the low polarity and the middle polarity part. So for the high polarity part, they don't have so many compounds. But for the for the aquilaria trees, you in the butanol part have a lot of compound, because I showed in one slide here some compound connected with the sugar. So this kind of compound, the polarity is very high, so can go to the butanol part. And then after this, we use column. Here we have different column, ODS and FKIP and silica and MIC. At the beginning, we usually use silica gel to separate them, to use reduce pressure and to separate them firstly, and then for the cis-quaterpine later we mostly use the column is still the silica gel, because this kind of compound the polarity is very low. So the mostly use we still use silica gel, and the solvent usually like petroloid ether and acyl acetate, or with some acyl acetate, or with the what's the name? And also sometimes we use three different solvent, but it's according to the compound. And for to separate some chrome, where we mostly use is chloroform and some methanol. So to separate, but usually for the chrome, after that we use ODS. We also use ODS to separate them, and also use FKIP, and after use FKIP and ODS, usually we have to, and also MIC sometimes also use, because some have the color. So MIC actually for MIC have some similarity with the ODS. For ODS, we usually use methanol and water. And then after this, the chroma use always go to the HPLC. For HPLC, we have several columns, carbon 8, carbon 18, and also also the pi, also another is not a carbon column. What's the name? I cannot remember very clearly now. And but it's a solvent, usually methanol, water, and also some
Acetonitrile.
oh
Acetonitrile?
yeah. Also we use, and then to repeater and use always we have use different column and to first time yes, so different time use different column and to separate the same, because only one column for the HPLC also limited. So different column and different solvent used together. Yeah.
Oh.
Yeah, to separate, and then finally get a pure compound. Yeah.
It's so many steps.
Yeah, I think it's for the procedure maybe similar. Just according to your sample, you have to know how to select the column and the solvent. Yeah.
Kan pertanyaannya Bu ditambahin Bu ya, Bu Rini. Yang untuk ini kolomnya itu kan itu ada ODS, Sepadex sama silika. Nah, apakah itu diterapkannya bergiliran atau misalkan ada yang pakai ODS, misalnya kalau antara ketiga itu misalnya ODS, Sepadex sama silika, yang mana yang paling baik atau paling banyak menghasilkan senyawa yang bisa diisolasi gitu.
Okay. Mr. Chen, there is another question from Mrs. Ira Lestari.
Yeah.
She asks, this type of column, ODS, Sepadex, and silica gel, which one is the best for the separation? And whether we need to do one by one, for example, ODS first, and then Sepadex, and then silica, or how do you arrange to use this type of column, and which one is the best to give high yields of compound?
It's difficult to say.
It's difficult to do. It depends, right?
Yeah, because usually at the beginning we use silica gel, and with very this kind of column. It's not long and thin, but it's wide. Usually very wide and short. With silicon, and because in this case we can separate very quickly. At the beginning we want to separate not so detailed, but we have to one part and one part quickly. And
do you mean VLC?
Oh yeah, VOC and VOC, and also, but sometimes we also use ODS. When the sample the amount is not so large, so big, so we use ODS to for the VOC first. But most of the time for Agarwood we use silica gel, and then usually for the Sepadex to separate some, for example, if have some chrome, so the dimer and just the chrome, you use the Sepadex to separate them, because the dimer the molecule is bigger, so can come down very quickly. But only the single the single chrome can will come down behind, so you can separate very well. But because the amount is very large, so we usually use not only one time, usually two two columns together to, because sometimes maybe you have several gram, so we have to separate to some for one fraction to separate to the self-dex. And then after that, then combine the same similar fractions, because later the compound is too much. If only work one part is not enough. So and then and after that, then use for the single column, then we use self-dex, ODS, and silicon. Most of them maybe use just the normal column. And the column dimer usually go to the ODS. After that, use ODS to separate again, and then directly go to the HPLC. Because for the dimer, use silica gel is not separated so well. So when we find this fraction is most of them is the dimers, so we will after the ODS directly go to the HPLC and use HPLC to separate them.
Okay. Thank you, Ms. Huiqin.
Welcome.
Okay, I think this is it. That was the last question. Thank you, Dr. Huiqin Chen, for the talk. It was really interesting and very inspiring for us to see how the hard work done and give really, really big results for this. And we are waiting for another inspiration from you and your team.
Thank you, Rainy. Also, I'm very happy we can share. Okay, my internet is not so good. Can you hear me?
Yes, clearly. It's very clear.
Oh, okay, okay, because it shows the internet have some problem. Yeah, I'm really happy to see you and Tony.
Yeah, me too.
Really? Yeah.
More chance.
So do we.
Me too, Huiqin. That's why I didn't give the class today. I need to sit down.
Yay!
Nice, Tony. Really, I'm really happy when
Me too. Yeah.
Yeah.
It's like you give your seminar.
Yeah. Yeah, so from deep down our heart and represent of my study program, we would like to thank you very much to Dr. Huiqin Chen for giving the talk and for coming here and yeah, to give us this kind of inspiration. So from us, there is one of kind of, I don't know what can you say about this, but I would like to give this opportunity to Untan to pronounce to mention it. Please, Untan. Can you unmute your voice?
Oh yeah. Now yeah. Okay. Yeah.
Untan?
Yeah.
We cannot hear you, Untan. And Huiqin, could you please stop share and close your screen?
Yeah. Okay.
Great. Thank you. Yeah, there is a certificate that we would like to give to you, Huiqin, for our thank you.
Sektor itu lagi ada ya.
Here, we would like to appreciate with what you did for us. So this is a certificate for you, Dr. Huiqin Chen. for your participation in this guest lecturer activity on theme effective and selective methods for the extraction and isolation of bioactive natural product from tropical plants. So on behalf our head of department, Mr. Rahmat Rasmawan, who cannot attend here because he is now in Makassar. Once again, we would like to say thank you to you.
Welcome, Lenin.
So perhaps later on we can continue with another collaboration.
Yeah, of course.
Yes,
Yeah.
of course.
Thank you.
And Huiqin, we also have here in our colleague. She is one of our senior actually in our study program, Dr. Annie Enawati. Dr. Annie Enawati, are you here?
Yes, yes. Ada.
She can also speak Mandarin.
Oh,
Huiqin.
Oh, yeah.
So,
你好。
Ya, halo.
Yeah. Hello.
Ya, Huiqin Chen ya. Mungkin panggilnya Huiqin ya. Huiqin ya.
Huiqin.
Huiqin ya. Oh ya. Mungkin apa? Ya. Kita speak Mandarin ya.
Bueni, you can speak Mandarin, Bueni. Huiqin,
Yes,
she's her grandparents is coming from Hainan.
呀，
So yeah.
哦，
ya, 我的母亲是apa? 在海南出生的。听见吗 ？Hello， kedengaran nggak ya?
yeah.
Hello， ya， 慧姐
Yes,
啊，
we hear you.
爸爸是从海南来的。
哦，
我
我听懂了。
你是海南的，住在海南，都出生在海南。
哦
Hello，
，it's great, yeah.
kedengaran nggak dia? Halo。
Huiqin, can you hear Dr. Annie Enawati? Miss
Yes,
Annie? Yes.
Yeah.
I would like a clarification here. Is it Mandarin or is it Hainan accent?
It's Mandarin.
Oh, Mandarin, okay.
Yeah. apa？最近你会讲海南话吗？
我不会。
哦，呀。你现在住在哪里？
我是浙江人，不是海南人，所以我不会海南话。
但是你现在在哪里呀？
我现在在海南。
哦。但是不会讲海南话。
对，不会讲海南话。我是工作在海南，对。
我在那边工作呀。
哎，对，是的。
哦呀，我是印尼人，但是我的父亲是在海南岛出生的。那所以我从小也会讲海南话一点啦。
哦。
我还没去过海南。
希望你能来啊。
在泰国比较，所以我们没有去哪里。呀，今天是很高兴听你的讲你的职业呀。
我也很高兴，是。
OK， 昨天Ibu Dini讲的，jadi ya， 又不真是一点来呀。谢谢啊，你可以给我们讲你的研究，让我们的学生也可以理解。谢谢。
谢谢，我也很开心，很高兴能有这个机会跟大家分享一下。
Ya, 谢谢啊。Oke, Bu Dini, tadi saya cuma terima kasih dia sudah memberikan pembelajaran untuk mahasiswa kita, sehingga kita itu bisa mengembangkan pembelajaran kita, pengetahuan kita. Itu aja.
Terima kasih Bu Eni. Okay. Finally, Ibu Enawati give me the explanation what they are talking about. Okay. All right, then maybe later, I hope in the future, we also can go there, Ibu Enawati. can go to Hainan, and yeah, we can come visit Dr. Huiqin Chen there.
Yeah. Welcome. Always welcome. Yeah.
Jalan ke sana.
Yeah, sure, of course. Next trip. Okay, maybe because in the beginning we cannot make a good photo session right now. What about we make another photo session again? Once more. Right,
Yeah.
Intan? Are you ready, operator?
Yes, Bu.
All the audience, please open the camera.
One,
Moment. Wait a second. Not all of them. Not yet. Yaseti, Melfi, Sita, Natalia. Could you please switch on your camera via okay, only this one? Only this? Okay, then Intan.
okay. 1, 2, 3. Once again. 1, 2, 3. Okay, finish.
Thank
Thank
you.
you. Thank you.
Thank you.
Thank you, Dr. Huiqin.
Welcome.
Dr. Huiqin, please send my best regard to Professor Dai and Hawang.
Yeah. I will. He knows because before this I already talked to him, so he he said yeah, it's very good. He said maybe later we also can make some cooperation. Yes.
Great. And Dr. Ola, next time it's your turn.
All right, Huiqin. When my turn, then you will come to Indonesia, Huiqin.
No, to Pontianak.
Yeah.
Yes. I hope I also can visit you.
Yeah.
Langsung ditodong Pak Antonius.
Yeah.
Okay,
Yes.
so this is it. I would like to close our activity today. Thank you very much, all the audience. I would like to close with salam. Assalamualaikum warahmatullahi wabarakatuh. Have a good day.
Yeah. Have a good day.
Thank you.
And
Terima kasih, Dr. Rini, for the invitation. Thank you very much.
Thank you.
Welcome, pleasure. I would like to invite you also, Dr. Ola,
Thank
to
you.
speak here in our class.
Yeah. Thank you.
See you next time then.
See you. See you.
Thank you.
See you.
See you.
Yeah.
Bye-bye, Huiqin.
Bye.
I miss you.